Hello students, welcome to Automotive Component Design AUT 306. AUT 306 Automotive Component Design. We are in module 2. In the first module, we have seen some introductions. Particularly, we have studied about some failure theories. In the from second module onwards, 2 to 5, second module, third module, fourth module, and fifth module. In all the four modules, we are going to study about certain design consideration for certain automotive components, particularly about shaft, connecting rod, piston, cylinder, then springs, um, brakes, clutch, and then some kind of couplings. All those things we are going to study in the rest of modules. Okay, so in the second module we are going to study about, particularly we are going to study about design of shafts. Okay, so in three ways we can do shaft designing. First, first one is by considering the strength. Okay, based on strength, shaft design based on strength. So this is very simple. For this, we will be using this formula: tau max equal to 16 pi d cube into mb square plus mt square, where mb means bending moment. Okay, bending moment of the shaft. mt mt means torsional moment of the shaft. mb means bending moment. mt means torsional moment of the shaft. D means diameter of the shaft. We are going to design the shaft. That means we have to find out the diameter of the shaft. That is our task. Okay, so they will be giving some power of the shaft and all those things. We have to find out how much dia it should have. Okay, for a safe purpose, for a safe design, how much dia it should have using uh, strength basis. Okay, second one, shaft design on torsional rigidity basis. Okay, in three bases we can uh, select the diameter. First one based on the strength basis. Okay, second one torsional rigidity basis. For this we are going to use this formula: d power 4 equal to 584 into mt into L divided by g into theta. See, these things you might have studied in uh, I think strength of materials. In that paper you might have studied this relationship: tau by theta equal to cj, sorry, um, tau by r, I think so. Tau by r equal to c theta by L, like that a formula is there. Okay, so from those things they have derived this formula. Okay, d power 4 equal to 584 into mt into L divided by g theta, where mt is torsional moment. Okay, L is length of the shaft. Okay, L is length of the shaft. So theta means angle of twist, L means length of the shaft, then mt means torsional moment, then g means rigidity modulus, d means diameter of the shaft. Okay, then this theta value, angle of twist will be between 0.25 degree to 3 degree. Okay, between 0.25 degree to 3 degree based on the application. Okay, for machine tool applications it should be 0.25 degree. Twist should be very less. Other transmitting elements, twist is allowed up to 3 degrees. And modulus of rigidity value, that is G value. G value is between 79,300, that is 79 kilonewton per mm square to 80 kilonewton per mm square. Okay, mostly they will give the value. Suppose if they didn't give the value, means you have to take it as 79 or 80. So second one is over. Third one, based on the ASME code. based on the ASME code design the shaft. So for this formula is d cube equal to 16 divided by pi tau max into root of kb mb square plus kt mt square. Okay, kb mb square kt mt square. So the same formula, same first formula, but the same first formula we have seen here, no, same formula only. Here also they have used the same things, but they have included kb and kt extra. Okay, same formula which we used in strength basis, it is going to use it again. See, tau max came here and d cube went there. Yeah, that's a small change. Okay, they brought the tau max to down and they brought the d cube here. Now we will see what is this kb and kt. Kb means combined shock and fatigue factor applied for bending moment, applied to bending moment. Okay, fatigue factor for bending moment. Kt means fatigue factor for torsional moment. Okay, kb means fatigue factor for bending moment. Kt means fatigue factor for torsional moment. Mostly they will give the kb kt value, otherwise they will tell the condition. Based on the condition we have to select the value. So in the second module, first portion is about design of shaft. Design of shaft, in three methods we can do the design of shafts. Number one, based on the strength, based on the strength. Second one, based on the torsional rigidity. Third one, based on ASME code. So these are the three ways. Now we will solve one problem based on strength. Okay. So here this is the question: the layout of a transmission shaft carrying two pulleys. See, I am using design of machine elements Bandari book, Bandari textbook. Okay, design of machine elements. Author is Bandari. So you can found this book in the net. Otherwise, in the next video, I will attach a link for the book, link for the textbook, link for soft copy of the textbook. Okay. So from that book, I have taken this example problem, 9.1. The layout of a transmission shaft carrying two pulleys B and C and supported on bearing A and D is shown in figure. So so now you can see this picture. So this is a shaft. This is the shaft, and this shaft is attached on two bearings. Number one, A, first bearing. Number two, D. So this particular shaft is attached on two bearings, and then it is getting power from pulley B. Okay, it is getting power from pulley B. Now we'll go to the question back. Power is supplied to the shaft by means of a vertical belt on the pulley B, which is then transmitted to the pulley C carrying a horizontal belt. The maximum tension on the pulley B is 2.5 kN. So this is what they have given. So let me change the color so that you can easily point out. So this pulley B, is a input pulley. Okay, it is getting power through some belt. Okay, So through belt, this pulley has been rotated and it is getting the input power, and pulley C is the output pulley. Pulley C is the output pulley. Okay, va? So in both the pulleys, belt were attached. Okay, in both the pulley, belt were attached. For example, suppose if you take pulley B means, so this is pulley B, and in pulley B, this is pulley B. Okay, so here belt were attached in the downward direction. Okay, so it is kind of load will be in the downward direction. Okay, well, so this is pulley B and it is giving the power to the shaft. So in the same shaft, pulley C is attached. Pulley C is attached. Okay, well, but in pulley C, belt is connected in horizontal direction like this. Okay, belt is connected in horizontal direction. So in the same shaft, two pulleys were there. In the same shaft, so for example, if the red line is the shaft means, in the same shaft, two pulleys were there. First pulley B and second pulley is C, and first pulley and both the pulleys are connected with some kind of belt arrangement. Okay, suppose if you go to some rice mill or some flour mills means, you can see these kind of pulleys. Okay, they will be arranged in such a way that it could transmit input power, output input power to other shafts. Okay, so similar to that, here a shaft is there. Shaft is BC. Okay, BC is the shaft, and on the BC shaft, two pulleys were there. Pulley B, that is input, and pulley C, that is output. Okay, through pulley B, input is given, and through pulley C, output is taken. And in pulley B, the belt were connected in vertical arrangement like this. Okay, you can see this green line now, vertical arrangement. But in pulley C, belt were connected in horizontal arrangement. Okay, so only here they have mentioned the forces like that. So you, in the side view, if you see means, you can see only two circles. Pulley B, so this is pulley B, and inside this is pulley C. Okay, on pulley B, the belt were connected in the downward direction. So force will be acting in the downward direction. But on the pulley C, belt were kept in horizontal direction. So force will be acting like this. Okay, I hope you can understand this question. Now what is our task is, we have to find out this diameter. We have to find out this diameter. Okay, they have given the speed of pulley B and forces acting on pulley B. We can find it out. Also we can also find out the forces acting on pulley C. Based on those forces, we have to find out the diameter. Based on the forces acting on the pulleys, pulley B and pulley C, and here in C and D, kind of reaction force will be there, because the shaft is fixed on bearings A and D. Okay, shaft is fixed on bearings A and D, and definitely some reaction force will be there on A and D, on shaft A and on shaft bearing D, bearing A and D will have a kind of reaction force on the shaft. So based on these forces, we have to find out the diameter of the shaft. Based on these forces, we have to find out the diameter of the shaft. Simply, in simple words, first we have to find out the forces acting on the shaft, and based on the amount of forces or based on the applied forces on the shaft, we have to design the diameter of the shaft. Okay, let's see further. Let's see the remaining data. So on the maximum tension on the belt is on the belt on pulley B is 2.5 kilonewton. Okay, the angle of wrap on both the pulleys are 180 degree, and the new value is 0.24. The shaft is made up of plain carbon steel, so they have given the maximum they have given the uh, tensile stress value. Also they have given the factor of safety as 3. Okay, we have to find out diameter of the shaft. Let me erase these pictures. So now let us write the given data. So they are given the tensile stress value 400 Newton per mm square, factor of safety 3. For one belt, that is belt on the pulley B, they are given the maximum tension 2.5 kilonewton. For example, I'll tell you this also. Suppose if there is a pulley, let us consider pulley B, okay, and on the pulley B, belt is, so this is the belt, like this is the belt, okay, this rectangular thing is a belt, and see the overlap, this is 180 degree, that's what they are given in the question. Theta value is 180 degree. Okay, belt is overlapped on the pulley around 180 degree. So see, that's what I have drawn here. Now they have also given tension on the tighter side. Maximum tension means on one side tension will be maximum and another one side tension will be minimum. So like if I consider this as tighter side means this will be P1 and this is slack side P2. Okay, so on the tension on the tighter side is 2.5 kilonewton. Okay, so this is what they have given in the question. So the formula which will be used to find out the diameter is this formula. Okay, because this is based on the strength we are going to design it. So tau max equal to 16 by pi d cube mb square root of mb square plus mt square. So in this formula we have to find out the d cube value. Tau max value they didn't give mb value, they didn't give mt value. We are going to find out this value. First let us find the tau max value. So tau equal to maximum tensile stress divided by, okay, sorry, SY means shear stress, okay. SY means shear stress. Shear stress will be equal to half of the maximum tensile stress, okay. commonly shear stress will be equal to half of the maximum tensile stress. In this given, they have given the tensile stress value. Tensile stress value is 400 Newton per mm square. Tensile stress value is 400 Newton per mm square, but we need uh, maximum shear stress. Okay, or tau max we need. So for that we need the uh, we need tau max permissible shear stress we need. For that we should know the maximum shear stress, but we don't know maximum shear stress value. So maximum shear stress value will be half of the tensile stress value. Maximum shear stress value will be half of the tensile stress value. So 0.5 into 400. 1 by 2 now, 1 by 2 means 0.5. 0.5 into 400 divided by factor of safety. We got tau max value was 66.67. We got tau max value. Okay, maximum permissible shear stress is 66.67 Newton per mm square. Right. One data we found. We need two more data, MB and MT. Okay, we need two more data, MB and MT. Okay, so they have whether they have given any other data like power or anything else. Let us see the question once. Whether they given any power value? I don't think so. They didn't give any power value. Okay, next we will find out P1 P2 value. Okay, P1 P2 value first we will find. P1 they are given 2.5 kilonewton. Okay, P1 2.5 kilonewton. And one more thing, MT means torque. Okay, torque on the shaft. Torque on the shaft will be equal. Anywhere you take, torque on the shaft will be value will be equal. Okay, whether you take at this point or at this point or at this point or at this point, wherever you take, torque on the shaft MT will be same. Okay, rotatory torque is same. To find out the MT value, there is a formula. Okay, there is a formula. We suppose if we got P1 P2 value means, suppose if we got P1 P2 value means, torque means force into distance. So P1 into R1, that is this radius. What is the distance between the center and this force? R1. Okay, P1 into R1 will be moment or momental torque. So total moment about this point will be, total moment about this point will be P1 R1 minus P2 R1. Okay, so like this. Suppose if you take moment about this center, moment about this center, otherwise this center. Okay, moment about this center means the value will be like this. That will be, sorry, MT, momental torque about the center, equal to P1 R1 plus, sorry, minus, because one is counterclockwise. This is in counterclockwise direction, but P2 is acting clockwise, so minus. So for counterclockwise plus P1 R1, but for clockwise minus P2 R1, same dia. So R1 is common, so MT equal to P1 minus P2 into R1. Okay, for this bully, for bully B, momental torque at this point, momental torque value will be equal to P1 minus P2 R1. Suppose if you found for bully C means, it will be like this, MT equal to at C. Okay, at C how many forces are there? In C also two forces, but they were in horizontal direction, P3 P4. Okay, one is acting clockwise, another one is acting counterclockwise. Okay, this is acting clockwise, but this P4 is acting counterclockwise. So it will be like P4 R2 minus P3 R2. So we can write like this: MT equal to P4 minus P3 into R2. See, I told you throughout this shaft, wherever you take, MT value is same. So this MT will be equal to this MT. Okay, this MT is equal to this MT. So this is how we are getting this formula. Okay, now let us jump into the problem. So right. So we have P1 value. Uh, if I know P2 value, we can find out MT value. Okay. We have to find out MT value. The thing is, we have to find out MT value. If I want to find out MT value, means momental torque equal to force into distance. Okay, momental torque equal to force into distance. Here, if you take any point, if you take this point, means here two forces are there. At this point, around this point, two forces are acting. Okay, around this points also, two forces are acting. Okay, let me take this point, this first point, around this point, that is around this point, two forces, P1, P2, two forces were acting, P1 minus P2 into R1. Okay, but still I don't know P2 value. I know P1 value, but still I don't know P2 value. So for that only we are having this formula: P1 by P2 equal to e power nu theta. Okay, in I think in design of transmission elements or in DOM you might have studied about these things. Okay, design of rope, design of belt, there you will have these kind of formulas. P1 by P2. P1 means tension on the tight side, P2 means tension on the slack side, equal to U mu theta. Mu means frictional coefficient value, theta means angle of wrap. Okay, here angle of wrap is 180 degree. We cannot put the degree value directly, so I have to put it in radian format. So for me the theta value is 180 degree. I have to convert this into radian format. To convert any degree value into radian format, you have to multiply the particular degree into pi by 180. Okay, so 180 cancel, remaining answer is pi. So only here nu value is 0.24 and theta value is pi. So take your calculator, first of all solve 0.24 into pi, find the value, then e power, put e and put this value 0.24 into pi, you will get 2.125. You will get 2.125. So we have to find out P2 value. So bring P2 here and bring the 2.125 down. Sorry. So we'll get 2500 divided by 2.125. The final answer is 1176 Newton. So now we got P2 value. Already we have P1 value. Substitute both P1 P2 value. They have given the radius value. Radius of the bully they have given in the question. So take the value and write it. So MT we got 330882. 330882. So we got one answer. MT we got. Still we need MB value. Okay, still we need MB value. MB means bending moment. Before we find the bending moment value, we need to find out P3 P4 value. Okay, before we move on to bending moment, we have to find out okay, I couldn't erase it. Check. So I have to find out P3 P4 value. So there also I told you, no, P3 minus P4 into R2 equal to MT. Okay, wow. So P3 minus P4 equal to MT value I have 330882. P3 minus P4 into R2 equal to 330882. If you divide this with 125 means I am getting the value as 2647. Okay, 2647. Now I have this relation now, P3 by P4 equal to P3 by P4 equal to E mu theta. Okay, or theta angle of wrap is pi and nu is 0.24. So the value is E mu theta value is 2.125. E mu theta value is 2.125. Okay. Now I have a format P3 equal to 2.125 P4. Okay, P3 equal to so I can say no P3 equal to why it is doing like this P3 equal to 2.125 P4. Now substitute this value here. Okay, now substitute this value here. Instead of P3, you just put 2.125 P4 minus P4 equal to 2647. If you solve means you will get a value. You will get P4 value. After that, you can find out P3 value also. Okay. So now we got P3, P4 value. Now we have to find out MB value. I am telling you again from the beginning, the formula is tau max by 60 equal to 16 divided by pi d cube into mb square mt square. We have to find out this d cube value, that is this diameter we have to find out. In the question they are given tau value. Okay, in the question they are given tensile stress value. From tensile stress value we out shear stress value, allowable shear stress. So one value we got, still we have to get MB value and MT value. Still we have to get MB value and MT value. For that we have to find out all the forces acting on the shaft, P3, P4, P1, P2. After that we have to find out the reaction forces on the bearing also. Here some reaction forces will be there now. That also we have to find out. Okay, if we find out all the values, then only we can find out MB value. First let us find the MT value. MT means P1 minus P2 into R1, that is MT. Otherwise P4 minus P3 into R2, that is also MT. Okay, so based on that formula we got MT value. Now we will move to next slide. There we are going to find out the MB value. To find out the MB value, we have to draw shear force diagram, bending moment diagram for the. No need to draw shear force diagram. We have to draw bending moment diagram. We have to draw bending moment diagram for the shaft. To find out the bending moment value of the shaft, we have to draw the bending moment diagram. Okay. So first let me take the vertical forces. So first draw the given free diagram neatly on the paper. Okay, like this, using pencil. So this diagram is given in the question. This one diagram is given in the question. First draw it. Okay. So first draw this diagram. After drawing this diagram, draw a so in two ways forces were acting. In vertical direction also forces were acting. In horizontal direction also forces were acting. So in vertical direction like P1, P2. In horizontal direction P4, P3. In two direction forces were acting. Okay. So first let me take the vertical forces. Anyone you can take. First let me take the vertical forces. So draw the line diagram for the given beam. Okay. Draw the line diagram like this. Draw the line diagram for the given beam like this. Okay. Straight line. I couldn't draw it. Draw the straight line. Okay. Draw a straight line. Don't want to draw. They have in the book they have drawn like box. No. You just draw a straight line. That's all. Okay. You just draw the straight line, and here on the vertical plane. Okay, on the vertical plane under point B, under the pulley B, vertical loads were acting. Okay, under pulley B, vertical loads were acting. The vertical value load value is P1 plus P2. Okay, P1 plus P2. So previously we found P1 P2 value, no, 2500 plus 1176. Add both. Okay, you will get like 3676. Yeah, 3676. Okay, that is the load value. But we don't know the reaction force value. Okay, on this place reaction force will be there like this. So we don't know the reaction force value. So we will take this as R AH. Okay, wow. Sorry, vertical, no. So RAV. This is RDV. So RAV, RDV I have to find out. Okay. But they didn't give the RAV value, RDV value. That I have to find out. How I can find out RAV, RDV value? If you know shear force diagram, bending moment diagram means that concept, if you remember, means in strength of materials we have studied shear force diagram, bending moment diagram. If you remember that concepts, you can easily solve this problem. Okay, I have to find out RAV value, RDV value. So sum of upward forces will be equal to sum of downward forces. So so I can write like this, no. So RAV plus RDV equal to downward force 3000. Okay. So sum of upward forces equal to sum of downward forces. Two forces acting in upward direction, RAV, RDV. That will be equal to one force which is acting downward direction. Next, what I can do, I want to find out RAV, RDV. Then only I can solve this problem, otherwise I can't solve it. Okay. How I can find out those values? Okay, right. Next, let me take bending moment at any one point. Any one point, you just take the bending moment at D or at A. At both the points, bending moment value is 0. Okay. Let me take point A. Okay, let me take point A. So MA equal to 0, which is equal to, so I have to find out bending moment about point A. Bending moment about point A. How many forces are there except RAV? Two more forces were there. 3676 and then RDV. Two more forces were there. So 3676, no? What is the distance between 3676 and point A? The distance is 200 meter. Okay. So 3600. Okay. So this is acting counterclockwise. So here plus is there. Next force Next force is RdV. Still I don't know the RdV value. Okay, next force is RdV, that is acting first one is acting counterclockwise. First one is acting clockwise, so minus, but RdV is acting counterclockwise, no? So plus. RdV RdV. What is the distance between D and A? Distance is 200 plus 600 plus 200, 1000. Distance is 1000. Okay. So here 0, here minus 3676 into 200, here RdV into 1000. So bring it this side. So you will have like this 3000. Okay. So if you cut this 1000 with this, means you will get the answer as 3.676. Now multiply it with 200. If you multiply with 200, means you will get 3 into 200. Okay, 3 into 200, 3.6 into 200. 3.6 into 200, you will get RdV value as 735 Newton. So this is what they have written here. In the book they have directly given the answer. Okay, in the book they will not tell you about these steps. So 735. Now I got RdV value. Now substitute this 735 here. If you substitute 735 here, means RAV will be equal to 3676 minus 735. Answer is 2941. Okay, 2941. So load diagram for this vertical load is over. Okay, load diagram for this vertical thing is over. Let me erase everything. Let me go to horizontal loads. Let me go to first. I have drawn vertical load. No? So for this vertical load, I got RDV and RAV value. Okay, 2941 and 735. I got the value. Now let me draw the bending moment diagram. Okay, don't want to draw shear force diagram. Directly you can draw the bending moment diagram, because we need to find out the MB value. Okay, we need to find out the MB value. Okay, so for that I am going to draw bending moment diagram for this vertical loads. Okay, so I know at point A and at point D the bending moment value will be 0. Always in the supports bending moment value will be 0. Since we have provided support, no, so there won't be any bending moment. Okay, except point A and D. What is the one more point we have? We have point B. Okay, we have point B. So we have to find out bending moment at point B. Bending moment at point B. Okay, so about this point from either this side or this side, take any one side. Okay, take any one side and see how many forces were acting. I am taking from this side. Okay, from this side I am taking. From this side about point B, only one force is acting. Okay, only one force is acting, that is 2941.18. So this reaction force is acting, and that too acting in counterclockwise direction. Sorry, that is acting in clockwise direction, but it is coming from left side, no? So I have to take that as positive only. I have to take that as positive only. What is the distance between point A and point B? Distance is 200. So 2941 into 200. That is the. Now I have to find out moment about point B. Moment about point B. Okay. So moment about point B means I have one force, that is RAV. So RAV value is 2941 into distance is 200 mm. Yeah. 2941 into 200. Okay. So the answer is 58,000, 5,88,232. That is the answer. 5,88,232 at this point. At this point we got the answer. Okay. Now we have to draw the same line for horizontal forces. In horizontal, P4, P3 is acting on C. Okay. So let me take the horizontal forces. So I have drawn both the forces like this, both horizontal forces like this. Okay. See, I can't draw like this. I can't draw like okay, horizontal forces. So at C it is acting like this. So I can't draw the forces like this. Okay. I have to draw the horizontal line only. I have to convert the horizontal force into vertical direction. That's all. Okay. Add P3, P4. If you add P3, P4 means you will get 7352. Now we have to find out this RDH value and RAH value I have to find. RDH value, RAH value I have to find. The same method. Okay. So RAH plus RDH equal to 7352. Okay. Now take moment about any one point, either this point or this point. Take moment about any one point. Okay. So let me take moment about this point. Okay. Let me take moment about this point. So moment about A. I told you at the extreme end moment value is 0. So moment about A is 0. So that will be equal to, it is in clockwise direction. So minus 7352 first force into distance. What is the distance between this point and this point? Distance is 800. Okay. Right. Over. Next, what force is there? Next, RDH is there. Okay. So RDH is acting in counterclockwise direction. So plus RDH. What is the distance between RD and RDH and RD and A? What is the distance? Distance is 1000. So similarly, so this side 0. So brought this value here. RDH. Bring this 1000 this side. So you will get RDH as 5882 Newton. Now substitute this value here and you will get RAH value as 1470 Newton. Okay. So now you got RAH, RDH value. Now we have to find out bending moment. Okay. Bending moment at both extremes is 0. Bending moment at both extremes is 0. So now I have to find out bending moment at this point. Okay. At point C. At point C I have to find out bending moment. So at C, bending moment value is for horizontal forces. Take any one side. I am taking this side. Okay. So this side, what force is acting? 5882, and distance between 5882 and the point C is 200. So 5882 into 200. That's all. Suppose if you take this side means 1470. Suppose if you take that side means that side one force is acting, that is 1470 into what is the distance between that point A and point C? 800. In both you will get the same answer only. In both you will get the same answer. So same answer. The answer is 1,17,000. Sorry, 11,76,470. That is the answer. So yeah. Okay, sir. You got the answer for this point and answer for this point. What about this point? How they got this answer? How they got this answer? Simple. Using similar triangle concept, they got the answer. Okay? Using similar triangle concept. Similar triangle concept means like um, for example, I need to find out this answer. Okay, but I have this answer. This answer I don't have. This particular answer I don't have. I have to find it. How I can find it? This particular answer. Very simple. Very simple. This particular triangle and this particular triangle are similar triangles. Okay, similar triangle means, that is what I am telling is, I will draw one more diagram and I will show you. You can't see this color. So this triangle, okay, this triangle and this triangle are similar triangle. Okay, this big triangle and this small triangle are similar triangle. If suppose two triangles were similar triangle means their breadth and height value will be same. Breadth and height ratio. For example, this breadth is B1 and this height is H1, and this big breadth is B2 and that height is H2, means B1 by B2 will be equal to H1 by H2. Okay, so for similar triangle, this is the concept. Erase all ink on slide. What is this? It is not erasing. Okay, now it's gone. So based on that similar triangle concept, uh, I can write like this. I told you no, B1 by H1 equal to B1. I'm getting this again. I told you no, B1 by H1. Why it is doing like this? Correct. So based on that similar triangle concept, here I have to write like um, 1176470 divided by this distance is 800. Okay, va? So see here. Ah. So based on the similar triangle concept, so this small triangle will be having the breadth height ratio that will be equal to this big triangle breadth height ratio. So for this big triangle, breadth is from this point to this point. Breadth value is 800. Okay, breadth value is 800. Height value is 1176470. For the small triangle, breadth value is this point to this point. Breadth value is 200. So height value I don't know. So h1 by 200 equal to, what is that height? 1176470 divided by, what is the breadth? Breadth is A to C, 800. Now you will get the answer as 294118. So we got this value. Yeah, we got this value. The same thing here also. Here also the same thing. We have 588232. We have to get the value here. This value we have to find out. Okay, va? So same thing. 588232 divided by the breadth. The breadth is from this point to this point. The breadth value is 800. Okay, equal to, now we need this height, no? So let me consider that as x. X divided by this distance is 200. If you tally means you will get x will be equal to 147058. So like this we got all the bending moment value. Okay, all the bending moment value we got for vertical plane, for horizontal plane. We got all the bending moment value. Oh, this method is nice. So, okay, thank God, everything has removed. So now bending moment at B. Now bending moment at B will be equal to 588232. That is vertical bending moment, and then 294118. That is horizontal bending moment. Okay, we have two bending moment at B: vertical bending moment and horizontal bending moment. I need resultant bending moment. Resultant bending moment equal to horizontal bending moment square plus vertical bending moment square. Okay, root. So the value is 657,664. Similarly, for bending moment at C, okay, at C also I have vertical bending moment 147058, horizontal bending moment 1176470. Square it and sum it, then root it. 1185625 we got. Now we need together answer we need. Okay, that is bending moment. So the maximum bending moment is at point C and the maximum bending moment value is 118565. That value we have to take. Okay. Empty value already we have 330. In the previous slide we got empty value. In the previous slide we got empty value. Empty value is so this is empty value already we have. Now MB value, 2 value we have 657664, 1185625. The maximum value is 1185625. So take the maximum value and put the MB value. Now empty value. So we got all the value. Now we will get d cube. Then finally take cubic root of d cube. Then you will get d value as 45.47. So this is how you have to solve this problem. To solve this problem, you need some basic knowledge from strength of materials also. Then only you can solve it. Very simple problem. Okay, very simple problem. They have given the question like this. Only one formula. Tau max equal to, this is the only one formula. Okay, this is the only one formula which you are going to use. But they didn't give MB value, MT value. First we have to find out tau max value. So to find out tau max value, they have given the tensile stress. So half of the tensile stress will be equal to shear stress value. So shear stress by factor of safety. So we got 66.67. So this is how we got the thing. We have to find out P1, P2, P3, P4. They are given P1 value. We have to find out P2, P3, P4 value. Along that, two forces were horizontal, two forces were vertical. P1, P2 vertical, P3, P4 horizontal. So for every horizontal and every vertical, we have to find out the reaction forces. First we have to find out this reaction force and this reaction force. Similarly for horizontal plane, this reaction force we have to find out. Then we have to find out bending moment, this bending moment and then this bending moment. Okay, we will get these two bending moment. Then based on similar triangle concept, we have to find out the extra bending moment. Okay. Now bending moment at B will be equal to this 588 and 294. These two things. Bending moment at C 147 and 1176. These two. Okay. Find the resultant value. The maximum value. Take the maximum value. 1185. Okay. 1185. That is the maximum value. Okay. And substitute in the formula. That's all. Thank you.